What I'd like to do now is to move on to Kristian Saether from Nordic Semiconductor.
Hi, Walter.
Kristian holds a degree from the Norwegian University of Science and Technology, over 18 years of experience in various roles, R&D, applications, marketing, product management, across a range of things such as microcontrollers, processors, UWB radar and wireless solutions. So certainly a breadth of activity there. So without more ado, Kristian, let me pass over to you.
Good, then I'll get going on my part. So thanks for taking some time to also listen to the Nordic part here. So quickly on Nordic Semiconductor first, because we are not a big legacy guy in DECT and maybe not known very much for people that are into DECT today. So we are a wireless semiconductor company, fabless, but we mainly make very low power integrated devices that are focused on wireless connectivity. So we have a big portfolio today around low power 2.4 gigahertz standards. We are venturing into Wi-Fi. We're our first Wi-Fi 6 solution later this year, and we have been established in the cellular market with LTM and IoT for massive machine type communication for 2 to 3 years. And we are now then starting to embark on our first products around NR+. So Nordic as a company has a long legacy and very long, 20-year plus in wireless technology. We, as you see from here, we really embrace and we like open standard. We think open standard is the key to build huge and very successful ecosystem. At the same time, we all realize that there's not one standard to rule them all, so you need a set of standards to ensure that you can cover everything and all the needs in the market. But when NR+ started, or DECT 2020 as it was called back then started, we looked at that, we became interested, and Nordic has been one of the main contributors on the physical layer that I will talk a little bit about today. And why did we do that? Here we saw basically opening up a license exempt and powerful 1.9 gigahertz band that can be used all over the world. And we have the ability here to also contribute and drive and hopefully influence the standard to become very, very robust, reliable, and future-proven in the sense that it can be used for many different applications, including IoT that we are focused on, of course, audio in the future for Nordic as well. So what and how do we in Nordic see the key advantages around NR+, and especially focusing on IoT and devices where we really are a big market player today on cellular IoT and Bluetooth Low Energy. So becoming a 5G standard is important for NR+ in the sense that as a standard, it's proven to meet massive machine type and ultra low latency and really high bandwidth applications. And today, you can't find any other non-cellular standard that can meet all of this requirement. You find only bits and pieces, and with NR+, we have been able to unify really a lot of very demand requirement into a very, very good standard. Also, you have a standard here that gives you good range with good bandwidth and very low latency, where today in the market, what you typically find outside cellular is low to medium bandwidth, very low latency, and questionable reliability depending on what standard you look at. So also here, NR+ is able to marry requirements that has been tough to meet in the past with other standards. And on top of that, you have reliability where you can really scale from hundreds of devices on a square kilometer to, as Jussi mentioned, more than 1 million devices per square kilometer. You can still achieve ultra high reliability, and all that reliability is really built into the physical layer, right? So you don't have to pile a lot of application-specific things on top of the application layer in order to meet very high reliability when you scale into massive IoT. And that's been a very, very big focus for us looking forward and see how NR+ can be used in the future. So quick summarizing a bit on feature set and mention it. You have really a global band here that can be used almost all over the world today. You have a standard that can support point-to-point star MS technology with very low latency operation. And by having able to do dynamic spectrum sensing, spectrum sharing, interference avoidance, you really have something that is very, very robust. If you think about something that is actually license exempt, so you can actually deploy networks and you can have many networks close together or on top of each other, and still you see them as very reliable. The physical layer is very scalable, as I will talk about later. You have very standard and up-to-date security that's based on AES with cipher chaining, and you can build very, very low power devices that operate on NR+ when you look at how the radio is designed and what, should we say, flexibility the application layer you have also to control how it utilizes the radio. So we see that as a very, very optimized standard for local decentralized applications. When you do single global bands, it doesn't only mean that the radio can be simplified, but if you compare it, for example, to cellular IoT, you typically building a global product. You need to compensate for a world where you have to have 700 megahertz something in some places of the world, up to 2 point something gigahertz in other places of the world. And that also put constraint on antenna tuning and everything else that you have to do on your hardware. And that's something that can be simplified with NR+. It's designed to make sure that you can provision and install devices very easily into a network. When you do to consumer devices like Thread, you allow and you accept that the consumer can onboard devices or provision devices into the network. But if you look at really scalable industrial systems, that cannot happen. Everything have to be autonomous and self-provisioned and still be very, very secure. NR+, when we talk about that with regard to 5G, I get lots of questions around that, and it is still a non-cellular technology in the sense that there is no subscription cost, there's no base station, you don't need a SIM card and things like that. So it is a truly non-cellular 5G technology also in that sense. There's very interesting research also going on about sustainability and energy and efficiency, showing that DECT NR+ can have really much higher energy efficiency than cellular network in terms of how it's deployed and organized. And as Jussi mentioned also, that each device are able to actually do dynamic control of how much power it uses to send data, which is not available for any other non-cellular radio standard today. So we see really that NR+ can be instrumental to drive Industry 4.0, where in industrial applications, if you really want high reliability and low latency today, you are tied to wires, and that's not going to scale in many of these applications. So now you can look forward to do automation, condition monitoring, building automation, lighting control, and a lot of other things with something that is very reliable with low latency and can scale to huge number of devices within a private network without any challenges on scalability. We also see that smart cities can be a very important application here for NR+. We already see from utility manufacturers, we see it from people building smart city infrastructure, smart lighting and other things, that getting access to a standard that can be used worldwide in a single band can allow big private networks and a standard that can support low latency or very high reliability, which you absolutely need in some of these applications when you talk about critical infrastructure or something that is around public infrastructure or transport, where you need very, very high reliability on the networks. So I'm going to quickly talk about a couple of examples and try to illustrate a little bit how we think around NR+ and why it can be such an important new radio standard for some application areas which haven't seen the deployments that we were maybe hoping for a few years back. So smart streetlights is something that is being deployed around the world. It's important for energy saving. It can be important for having dynamic light control or more real-time diagnostic and maintenance. So, for example, where I live, if there is street lights outside, and there the people actually, or the guys that run the street light, they rely on me as the guy living in the street reporting if the light outside my house is broken. So that can take a week or 4 weeks or 5 weeks before they fix it. They have no infrastructure to autonomously detect that, no infrastructure to maybe, beam up the other lights next to it if it's broken or do things like that. And that's something that you can do if you connect something and have it wirelessly connected or connected to a central place where you can see diagnostics for everything going on. We also see streetlight becoming more integrated. You can do environmental monitoring, you can do cameras for traffic monitoring, you can do speaker for information, and you can do a lot of things. And today it's hard to find a single radio standard that can do all that. What you can do with NR+ is you can scale to big networks. You have a very scalable physical layers. So you can envision nodes that have lower bandwidth if they're not so demanding, but also node with very high bandwidth. And you have self-organizing networks. So if the network fails, if the sink or the node, that gateway that sends data to the cloud over NR+, or LTM and NR+, is suddenly gone or down, the network can reroute to send data through other sinks or other gateways in the network. That creates something that is very reliable due to the self-organizing capabilities of the network. But we also, when we look at smart cities and other things and see the capabilities of NR+, we also think that this has capabilities and potential, far beyond just make sure that you have smart street lighting all around. If you imagine a city where you have streetlights that are connected over NR+, and that you have a very robust and big infrastructure here, you have gateways or sinks in places where you need to put the data up to the cloud. You can then imagine that you can start to connect other devices again to that infrastructure of streetlights, because you have the bandwidth, you have the capability of the network to scale, and you can really scale this using one single network infrastructure. You don't have to rely on different standards all over the place in order to connect things. So as you want to deploy more infrastructure that are connected in the city, could be parking sensor, could be smart trash bins or charging stations for bicycles or whatever. You can actually imagine that with NR+, as you deploy this, they connect to an existing infrastructure of streetlights, for example, which then are at regular interval. You have gateways that can connect the data and send it to the cloud. And since the network can scale and be autonomous, you can also put more gateways into the system if you need more bandwidth up to the cloud as you deploy more and more nodes. And you can do this without having to change your network infrastructure, your network technology, or start to deploy different type of technology to make sure that you can scale to bigger infrastructures or things in the future. Another area where NR+ is very interesting is for smart warehouses. In smart warehouses, you have already, and you will have, self-driving vehicles driving around the warehouse. You will have massive amount of connected equipment, some that are stationary, but also equipment that moves around. And here you are typically today bound with either very proprietary expensive systems or with wired systems. But wired systems cannot scale in this world where you imagine everything to be connected and everything to be wireless, non-stationary. So we also think that for warehouses and for factories where you do especially have moving stuff, where you have a lot of equipment that are necessarily not stationary, you can now equip them with NR+ connectivity, and you get really the reliability and the latency of wired connectivity without having to go to much more complex 5G cellular standards, for example, or try to find proprietary, non-proven standards that don't have an open ecosystem like NR+ would have in the future. With this, we also see, and we already see today, that it's really a lot of interest around building very secure private networking for these use cases. And then it doesn't only mean that you need to have security on physical layer, or you can pile on with end security, or should we say end-to-end security on the application layer. But here you also inherently have a private network, so you can control very much on the factory itself where you allow data connections to be done from the network and out to a cloud or to an outside world. Talking or showing a little bit of physical layer and the capability of the physical layer, I think it's good to know. And also I want to talk a little bit about Nordic and our product plans with regard to that. So as I mentioned initially, in Nordic, we have been driving the physical part of NR+ specification, and that's where we have strength in terms of experience and people, and we can build something since we are IC developer and develop chipsets for this. So when you do OFDM with NR+, that can scale to bandwidth from 1.7 megahertz up to 220 megahertz. And it supports modulation all the way from basic BPSK up to 1034 QAM, so extremely scalable. And at Nordic, we are starting at the lower end here, so we will support 1.7 megahertz and 27 kilohertz subcarrier spacing, and we will then support up to 16 quad modulation, meaning that our initial solution that we are bringing to market will go to 3.4 megabit of data rate, basically, if you look at on MAC layer or physical layer. So we are making our first solution really targeted towards application that need to be very low power, that need to be low cost, but they need to be massive in terms of deployments, IoT type devices. But it also means that we can support especially audio applications that are not too demanding in terms of capabilities. So all in all, we see NR+ as a very promising technology for customers that want to deploy massive amount of devices that have really low cost of ownership. Here you don't need base station, you don't need SIM card, you don't need subscription, and you have something very easy to install. At the same time, you have something that is very scalable and very reliable. No single point of failure, autonomous network. You can build very low power devices using NR+. You can be very secure system over NR+. And that means that putting millions of devices in one network, having ownership of that network, and having something that doesn't have single point of failure, we strongly believe that this has been a big missing piece, basically, in the IoT ecosystem in order to really make wireless IoT scale in industrial and other applications that need reliability and scalability well beyond what you typically would look for in consumer applications today, or home automation, or more, should we say, lower end type of application in terms of these level of requirements. Finally, talking a little bit about product plans going forward, and also a little bit about our partnership with Wirepas, which is important to understand in this product planning. So we have now moving with Wirepas as a solution partner, and that means that from a product point of view, we at Nordic, we are really focusing on bringing out hardware and doing the physical part, so the lower level part where we are really strong today. As Teppo mentioned, Wirepas is a software company really today. They don't make ICs, so they are really making the higher layer solution here to bring out very strong, robust, and reliable 5G mesh solutions. We are working close to be able to support, lead customer and people who want to start running with NR+ already from late this year, and then we are scaling up so we can support a more and more mass customer type of activities during 2023. It's a new standard with software stack and hardware stack that need to come together, so it's a bit of uncertainty still, of course, on how quick you can do things and how you get to a reliability level that enable you to scale with many customers. But this is what we're working to achieve, and what people that are interested with NR+ can look forward to in working with Nordic or Wirepas on that. We have just launched a landing page in Nordic that you can go to if you want to follow a bit more what we're doing on NR+, and you're going to go there and regularly see that we do updates. And please reach out if you have questions and want to discuss more. Nordic is also very interested to talk, right, to learn more, especially about audio and other applications where we don't have a lot of experience today.
Excellent. Thank you very much, Kristian, for that presentation. I think a lot of interesting things you covered there. How long has the company been going?
We have been going since 1980s, actually. So we are a fairly old company, but it started with basically ASICs and proprietary wireless things. So. Right.
So I mean that is quite a long time. I mean, that really is the early days of fabless silicon companies. Yeah. Okay. Have we got some questions coming through? Please do send some through. I've got a couple of my own. The first thing that caught my eye was when you talked about the sustainability issue and put up the figure of 60% improvement in energy efficiency over cellular. I presume that is comparing what with, is that with comparing with NB-IoT, or is it comparing the end-to-end energy usage, or is it just comparing the
on cellular IoT, or what we call cellular IoT, or narrowband and M1?
So, but that's covering the full end-to-end comparison, is it?
Yeah.
I think there was a reference on your slide that.
Yeah, there's a reference there, and if this material is put out, people can go and they can read themselves and see that. It's always interesting to see them, but people have different use cases and want to do different things. So it can be relevant for some people and not so much for others, right? So it's good that I encourage people to make that reading themselves as well, of course.
Yeah. No, I think it'd be very useful actually to maybe for the DECT Forum to sort of gather together some of those publications that have come out in examining some of these sorts of issues, because they are very much the kinds of questions that that people want answers for, I think, when they're looking at comparing different technologies. You mentioned low power, low cost, and I think audio as well as being your initial target markets. I mean, can you say a bit more maybe about sort of what shaped the thinking around that?
Yeah, so what we see today, and I think especially when we look at I would say cellular IoT especially, is that people want to deploy devices with many years of lifetime, also for industrial application, monitoring application, utility meters, and so on. And to do that, they also need to be able to really build good models and control how the radio is used. And there I see a big benefit with NR+. So with NR+, the radio can themselves really control how much power they output and how they utilize the network and how they want to connect to other devices and how often they want to send data. And this is in comparison to cellular IoT, especially where that the network is in control and really tells the device and demand from the device, how much output power, if you want to transfer something, how much many repetitions you want to use, what modulation you want to use, and so on. So it's hard for many customers to really estimate battery life with cellular, and there I think DECT as other, should we say, non-cellular standard has a big benefit in that sense. Looking at the portfolio of products we have today, we also believe strongly that we can really make ICs for NR+ also that have the same low power characteristics that we are already doing today with Bluetooth Low Energy and cellular, so that we can really equip people with solutions that can have many years of battery life from a couple of AA batteries with devices in the field. Yeah,
I mean, that's certainly been the holy grail that people have been looking for quite a few years now. So let's look forward to that.